Hello everyone, welcome to my YouTube channel. In the lecture of class 12th, today I will start function and types of function. Function is already studied in, you all have done that chapter relation and function in 11th class also. So you all know about the definition of function. Today I will recapitulate that definition and the new that is for class 12th, that is type of functions. Okay, let's start function and its type. So today my topic is function and its types. When you have started relation and function in class 11th, you all have done the definition of relation and function. So I will start from that definition. What is the definition of function? What is function? Function is a relation from a set A to B, from a set A to a set B is said to be a function, if every element of A has one and only one image in set B. There is one and only one image in set B, that is known as function. For example, we have one set A, one set B. This is A, this is B. Let us suppose this is equals to A, B, C, D. This is equals to X, Y, Z and W. So all the elements, different element has one and only one image in B. Like this. There is only one and one image in B. This is said to be a function. If the same terms, if the function, let us suppose we have a two sets A and B. Like this is A, this is B, and there is A, B, C and D. Here X, Y, Z and W is there. A's image is W, B's image is X, C is image is Y and C is also image in Z. This is not a function. This is a function because every element has only one image. In this C has two images. This is not a function, only a relation. This is only a relation, not a function. This is not a function, this is function. So this is a function. The first elements are called pre-images. This is known as pre-images. I will write again. Pre-images. And these are images. Okay. This is called, these elements are taken in the domain. You all know. These are range. And the full set. The whole set is called as, the whole set is known as codomain. So remember one thing, range is always the subset or equals to the codomain. Because whole set is known as codomain, that means it is a range is the subset of that codomain. So this is the study of class 11th. Now come to the types of function. How many types are there? There are two types. Important, only two types that are very, very important in the board exam. Either one question, there is internal choice of question of these this chapter relation and functions. There is either a choice between equivalence relation and one on two. Okay. The first types of function. Types of functions. First is one function. One function. What is this one? Make the definition like this name, one. That means the 1 1 function is that function in which every distinct object has distinct images in B from a set A. Okay, a function is said to be a function from x. We will write it as function f. I will not write it into the theory form. I will write it mathematically. A function f from x to y is said to be 1 1. Said to be 1 1 if images of distinct elements of A are distinct. Okay, images of distinct elements are distinct. Different element has different images. That is, if x1 and x2 both belongs to this x, that means first set, and fx1 equals to fx2. This implies if x1 equals to x2, we can say that this is 1 1 function. Otherwise f is many one function. Okay. So what is the definition? Tell us. Let us suppose we have two sets A and B. This is A and this is B, and the function that is f. Okay, A has A, B, C and D. Here 1, 2, 3 and 4. Okay, let us suppose A's image is 2, B's image is 1, C's image is 3 and 4's image is 4. So this is 1 1 function because different object has different images. So this is 1 1 function. Okay. In place of this, if we have A set and B set, this is A, this is B, and let us suppose this is a function f1. This is A, x, y, z and w, and this is A, B, C and D. If this is equals to this, okay, if I eliminate this from the set, this is B, this is for C and this is all for D. This both set has the same image. There should not be 1 1. That means it is many one function. Right? Many one function demands, the 1 1 function demands a different element has different images, but these both elements have same images. That means it is many one function. Okay? So this is the first type. Now this function is also known as injective function. This is also known as injective function. We can also say that this is injective function. Okay, now come to the second function, that is onto function. Onto. What is that onto function? That is also very easy. What is that function? Onto function demands for the set y. Onto says that what is onto function, or we can say that is surjective function. Onto, second is onto function, or we can, the other name is surjective function. Okay, onto function. What is onto function? A function f from x to y is said to be onto if for every element of y, if every element of y is the image of some element of x. Said to be onto if every element of y is the image of some element of x, that is, for y belongs to capital Y, there exists x belongs to capital X, such that f of x is equals to y. This is the mathematical way to solve it. Okay, what the definition tell us? Let us suppose we have two sets like this. This is A and this is B, and there is a function f. This is A, B, C and D. This is x, y, z and w. So how we can say that? Let us suppose A is y, the image of A is w, B is z, C is equals to x and D is equals to y. All the elements are some image of, this is 1 1 function as well as onto, 1 1 and onto function, because all the elements are images of some element of A. Now come to the another example in which we have, this is set A and this is set B. A, B, C and D. This is X, Y, Z, U and V. This is the image of Y, this is the image of X, this is the image of Z. Okay. This is the image of U. This is not a onto function because V remain as it is. V is not a image of any value of any set, any element of set A. It is not the image of any element of set A. It is not onto. If the function is not onto, if the function is not onto, then it is into function. Okay, it is said to be into function. That means it is not onto, matlab into function. It is into function, right? So this is the way to understand how we can take the 1 1 function or onto function. Now come to the examples. Come to the example how we can prove 1 1 and onto. How we can take the mathematical derivation of these functions, that is very, very important. Come to the first question is very simple. I will start from the simple questions. Question is, prove that, let us show and check whether prove that f from n to n, that means natural number to natural number, defined by f of x is equals to 2x is 1 1 but not onto. How we can prove? Very simple. Either you can take the example or you can take the general elements. Let x1 and x2 both belongs to natural numbers. Okay. When I start from natural numbers, I will take fx1 equals to fx2 according to the definition. If there is fx, I will take x1, that will equals to 2x1 equals to 2x2. I will cancel 2 and 2, x1 equals to x2. That means f is 1 1. Right? This is the way to show these two elements are from natural numbers. When we take the mapping, that is mapping, then we have a value x1 equals to x2. Both are equal. Okay. Now come to the onto. For onto, I will take one value. Example, 5 belongs to natural numbers. 5 belongs to natural number. You all know f of x is equals to 5. But f of x given as 2x. It is given as 2x. When I equate these two. 2x is equals to 5. So x is equals to 5 by 2. That is 2.5. That does not belongs to natural number. That means there is surely a number which does not have the pre-images. Matlab it should not be possible. This x which is the image of this one, this x is equals to 2.5, which is not possible. That should belongs to the natural number, but it does not belongs to natural number. Therefore f is not onto. Okay, it is not onto, right? But if the question is little bit change in this, there is little bit change in this question. What is that change? Then it become 1 1 as well as onto. What is the change in that? If the question is it belongs to real number to real number, then we can take the same 1 1 function. When we will take 5 belongs to 5, fx is equals to 5 and fx is equals to 2x, it belongs to the real numbers. Yes, then it belongs to real number and f is onto. In the case of real number, it is 1 1 and onto. Okay, so this is the way to solve the 1 1 and onto question. Now come to the bijective function. What is bijective function? What is bijective function? Bijective function is very simple. You all know, you all have done 1 1 or onto. The bijective function is bijective function. Bijective function. If the function is both, if the function is both 1 1 and onto, then it is said to be a bijective function. Okay, then it is said to be bijective. Bi means two. Bi means two. Two matlab 1 1 and onto both. Both function, if a function satisfies both by 1 1 and onto function, then it is bijective function. Okay, one more example from your NCERT. What is that? Prove that f from this is from NCERT, real number to real number defined by fx is equals to this, where this x is greatest integer function. Greatest integer function is neither 1 1, is neither 1 1 nor onto. This is a very important question according to your board exam also. How we can prove that it is neither 1 1 and nor onto? For 1 1, I will take the numbers from real numbers. Let 1 and 1.2 belongs to both taken from the real numbers. 1.2 belongs to real number. If I consider f of 1, that is greatest integer function of 1. If I take 1.2, that is 1.2, I will take 1 in place of 1.2. This implies 1 is 1 not equals to 1.2, but f of 1 is equals to f of 1.2. This should not be equals, but both are equal. Both different functions should have different mapping, but both different functions have the same mapping. That means f is not 1 1. Okay, this is not 1 1. It is not 1 1. Now how we can prove onto? For onto we will take the same concept. For onto I will take the same example. 1.7 or 1.3, 1.4, you can take any numbers. 2.3, let on 2 for on 2. I will take the number from let 1 point. I will take 2.3 belongs to 1. That is real numbers. ठीक है? fx is equals to 2.3. I want to find out the pre-image of this number. So for f of x is greatest integer function. When I equate these two, any greatest integer function will never be not belongs to greatest. That is not possible. The greatest integer function will never be in a point form, which is not possible. Which is not possible. Right? This implies f is not on 2. Right? Because every greatest integer function are the whole values, not the values in decimal. But by equating these two, we have a greatest value in the decimal form, which is not possible. Therefore, it is not on 2. So these are the definition and example of 1 on 2 types of function. Do these exercise and do more question for the practice of these functions. Okay, thank you.